Hello everybody and welcome back. Today I'm just going to do the fifth FRQ from the 1998 AP Calculus BC exam. So let's dive right in. Right off, we are told that the temperature outside a house during a 24-hour period is given by f of t equals 80 minus 10 cosine of pi t over 12 for 0 is less than or equal to t is less than or equal to 24. Our first task is to sketch the graph of f on the grid below. So that would be right here. And to do this, really, this isn't too hard. I think I'll just first plug in my endpoints for t into the function, because I think 0 will help as we end up with cosine of 0, which is 1. So that simplifies things a lot. And at t equals 24, where we will have 2 pi. And if you know your unit circle, you'll also be able to recognize that cosine of 0 is equal to cosine of 2 pi. We have f of and then 0 equals 80 minus 10 times 1, because cosine of 0 is 1, which equals 70. So I'll plot that point. Next we have f of 24 equals 80 minus 10 times cosine of 2 pi, and I'll just write that out to be more explicit. And this is also 70. So we have those 2 points. And now what we just want to find is if we can maybe get a point towards the middle, maybe at t equals 12, because that will simplify our thought process. What we can notice is that if we substitute 12 for t into our expression, we get cosine of 12 pi over 12, and the 12s will cancel and we'll get -1 for cosine. So let's do that. So that would be f of 12 equals 80 and then minus 10 times -1, which is 80 plus 10, which is 90. So I'll plot that point. And now we can draw our graph. Now, I realize this graph isn't perfect and it does not have perfect curvature, but it does the job. It has the right shape and it includes those absolute minimums and maximums on our given interval. So that's part A. So for part B, we have find the average temperature to the nearest degree Fahrenheit between t equals 6 and t equals 14. So just using the basic integral averaging formula, that would be the integral from 6 to 14 of f of t dt over 14 minus 6. And when I plug this into my calculator, what I get is 87.161 degrees, which is approximately 87 degrees. And that is our final answer for part B. Now, I recognize that you could solve this integral by hand, but to find an exact answer with the given bounds, you would have to use a calculator. But if you guys would like me to show you how to solve an integral like this, I will. Just leave a comment in the comment section and I will make a video about it. Let's get into part C. We are told that an air conditioner cooled the house whenever the outside temperature was at or above 78 degrees Fahrenheit. For what values of t was the air conditioner cooling the house? So we can write 80 minus 10 cosine of pi t over 12, I'll put that in parentheses, is greater than or equal to 78 for 78 degrees. Now I can subtract 78 from both sides and I'll get 2 minus 10 cosine of pi t over 12 is greater than or equal to 0. From here on out, we can solve for t, or we can just use our calculators. For simplicity's sake, I'm just going to plug this into my calculator and see when it is greater than or equal to 0. So I have graphed this expression right here, and I'm making sure to set my window so that my minimum x value is at least 0 and my maximum x value is at least 24. Now I'm just going to find the zeros of this expression, and I have t is greater than or equal to 5.230, and I'm truncating there, otherwise you would have 0.231, and t is less than or equal to 18.769. And this is our final answer for part C. For the final step of this FRQ, we are told that the cost of cooling the house accumulates at the rate of $0.05 per hour for each degree the outside temperature exceeds 78 degrees Fahrenheit. What was the total cost to the nearest cent to cool the house for this 24-hour period? So this is an accumulation problem, and for this we will need to take the integral dt from 5.230 to 18.769, and then what will be our integrand? Well, we have to remember that the cost of cooling accumulates at the rate of 5 cents per hour for each degree the outside temperature exceeds 78 degrees Fahrenheit. And as our integrand, we will have f of t minus 78, because that is the number of degrees above 78 degrees. And our limits of integration are the bounds for which the temperature outside the house is at or above 78 degrees. So I'll just plug this into my calculator, and that is, if I'm rounding to the nearest cent, that would be $5.10. And that is our answer to the final part of this problem. If you enjoyed this video, please give it a thumbs up and subscribe, and share it with somebody who will enjoy it. If you did not like this video, I'm sorry. Hopefully you'll like some of my other videos. And if you can, please share it with somebody who will like it. And I hope you have a wonderful day.